welcome Jason Maes to this amazing session on Meet Your Heroes. This is a kind of an podcast come a session that I really didn't actually expect to do, but this is happening because Jason Maes loves people. And not just he's the developer advocate of TensorFlow JS, but he has that tech mindset that really can fascinate any people. And I think the amount of influence that TFJS made for the entire world actually because of the way in which it was evangelized and also the amount of community support which it got through. And I think I'm deeply honored. And this is my humble attempt in order to understand what is going on behind the mindset of building the next future Jason Maes. And I don't care whether there's hundreds of Jason Maes coming out, thousands of Jason Maes coming out, but I would be happy that if one person get influenced by him, because I'm the person who literally got influenced. And now if I'm staying consistent in my learning of TensorFlow JS, it's because of him. So I welcome Jason Maes, sir. Thank you so much for giving me this podcast.
Yeah, and thank you for the wonderful introduction. I'm very humbled by that. And yeah, I hope people can get inspired by what we talk about today and hopefully answer some questions. So let's go for it.
This is my personal question. You've been building intelligence on different form factor, like on a web browser. Like that's what TensorFlow JS does. And I think Lawrence Mauney is some guy who is really exploring beyond it. He is in TensorFlow JS, TF Lite, and all the different technology. But I want to ask this to my hero, like, do you really fear intelligence that we are building today? Or else do you fear the form factor of the intelligence that we are building today? What's that? I just wanted to ask.
Sorry, do I fear the intelligence, did you say, of what we're building today?
Yeah, the artificial intelligence, machine learning.
Oh, I see. No, I do not, for the simple reason, as you go deeper into it, you realize it's just a bunch of mathematics working out. And, you see how like something simple like a multi-layered perceptron actually works behind the scenes. And it's just a bunch of, additions and multiplications, really. And it just adjusted over many, many tens of thousands of iterations. And you end up with this mathematical model that for most situations can predict some output correctly. So, I don't see that as, I don't fear this. I think often it can be seen or likened to the things you see in Hollywood movies, which is not correct. We're nowhere in that realm of artificial general intelligence, which is what you see in those kinds of situations. We're actually in a realm of narrow AI, which is where the system can do one or a few things as good or better than a human, but it's not a generalizable intelligence. It's just a bunch of maths working out. So now there's a bigger question, of course, as to what the human brain is. Are we just a bunch of generalizable mathematics going on in biology? But that's to be discovered and a subject for a whole different conversation right there.
Yeah, because there are different kinds of drivers which play a major role. I think the intent of JIT came inside the browser and it really changed the game of the way in which we perceive the browsers today. So I want to ask you this one question. Are we still adamant to the fact that there is still a different breakthrough that we are waiting for? Like, what is the breakthrough that we are actually waiting for to build an intelligence on a burning box? Like, we have an intent of cloud, we have an intent of edge now, and people have really built a brain to some extent. Like it's to some extent, but not completely a brain. What's the breakthrough that we are waiting for today?
I think at this point in time, I thought the next couple of decades would be more around the human and machine working together. So now we're starting at the very beginnings of like, okay, we found some data, we train a model, and it does a thing, and you can integrate that into your grander software engineering program to then make some intelligent decision. But I think the real value will come when we're using more systems that are working closely with the human. So in the medical industry, for example, we already have some of these things happening already where the AI programs can help the doctors find the brain tumor in a grainy medical image, that kind of stuff. And that's where the real power is, because the doctor in this case can find things before they even would see it normally. which is great for the patient. They get earlier diagnosis and more accurate diagnosis, and they can get through more content in a shorter time as well. And I think the same will happen for other industries as well as things progress. So I think this is a very exciting time, which is starting to come into its teenage years, shall we say, right now, and will mature as time goes on, and this become more commonplace, I believe, longer term as well.
Yeah, building Jason Myers was an years long of journey. I know that. And you were staying consistent over the course of time. And your LinkedIn game is something which is more phenomenal. I know why. If I say you something, do an ice cream, I think probably you won't do it. But if I ask you something, just go and build something on TensorFlow.js. Even if you don't know, you intend to go back to the documentation, just look something back, and the way you explain in any of the sessions, like I've seen most of your sessions on YouTube, and I was really fascinated by it. But I want to ask you this one question. What's the biggest mistake that we as students or the newbies of this world of deep learning and machine learning doing in learning something new like TensorFlow.js, TensorFlow Lite? Like, according to you, what's the biggest mistake that any newbies, like any person who is really learning something on deep learning or machine learning, is doing?
Well, that's a tough question. Of course, it's going to vary slightly from person to person, but one common thing I see when people are trying out TensorFlow.js, at least that I've seen from the community, is that people will try one of our pre-made models, such as object detection or the body pose estimation. We just released a new MoveNet model that runs super fast in the web browser and can identify the key points on your body up to like 120 frames per second in the browser. Really, really cool model. And I see people trying it out, and that's where they stop. I'm like, no. So this model allows you to do so much more than that. And I encourage people to put their creative thinking hat on. And TensorFlow.js, the team, which is the team I work with, provides these great research grade models available to everybody for free. But that's just the beginning. Being able to take some of these lines of code and run it is step one. But step two is to think about how you can then take these models to solve problems in your everyday life. And that's the step I would like to see more people trying to do. Not just, okay, I can run a machine learning model, I now know machine learning. No, that's the first step. The second step is to now use it for something useful and build your own custom logic upon that. So a good example of this is that I took the body pics model, for example, about a year and a half ago, and it can segment a human body from a given image, okay? And on face value, it's a cool model. You can get that demo running nicely. But I then decided to make it into something useful. I thought about problems that I have in my life. And the thing that I came up with was a clothing size estimator tool. So imagine on a website, you're about to buy some clothes, like a t-shirt or something like this at your famous brand's website. Now, often, if you're anything like me, I have no idea what size I am because I buy my clothes like once a year, and I probably got a lot fatter since last year because of all the things I've been eating. So I never know what size I am. So I figured if I could know where my body was in the image and I could segment it perfectly, given that most people know their height, with that information, if I input my height into the computer and I know all the pixels that represent my body, I can then figure out the kind of pixels per height measurement, if you will, to then allow me to measure any part of my body. So if I stand once to the front and once to the side, I can then have a guess of what my kind of, waist measurements would be, or inner leg measurements would be, or which I can then use to provide an estimate of a small, medium, or large for the t-shirt or trousers that I'm trying to buy online. And sure enough, I kind of thought about this when I was dreaming one day, and I thought, okay, let's have a go over the weekend. I had some spare time to try and make it, and I did. And I got accuracy within about an inch or so, maybe a centimeter to an inch in accuracy, which was good enough to allow me to then pick small, medium, or large at the checkout, something simple like that. And this was a prototype. It's definitely not production ready, but it proves that it is possible to do such a thing. And I'd like to see more stuff like that, going beyond just using the model and using it for a real world use case or a business application or solving a problem in your life. And I think that's where students have very creative minds, and I'd like to see them use that more for that kind of stuff too.
Because your team actually thinks about building neural networks on a different form factor, like on a browser. That's what
Mhm.
TensorFlow JS is all about. But I ask these questions to most of the people, like, would you think that uh, deep learning was invented, or else it was just a flow in which it was just thrown out to the world? Like, what is it? Was it invented or discovered, according to you? Because
So
we are building it on
yeah.
all different platforms, all different
Mm.
terrains, and it's making me crazy to think who is the father of deep learning, because there might be theories saying that, okay, this man invented it, this man invented this theory, but that it runs on an open source software right now. So Richard
So
Stallman should
yeah.
be the father now. So who is it, and what is it all
So I
about?
So the exact name I do not have to hand, but the actual concepts for deep learning and something like the multi-layered perceptron, or the perceptron itself even, actually goes back to the 1950s. And this is not a new idea. It's only now that we actually have the processing power with the new GPUs, the graphics cards, and the RAM and the CPU power at a cheap enough cost as well to be able to leverage some of the ideas that were proposed back in those days. So it's taken that many decades before the hardware caught up. And, a lot of this deep learning stuff was considered a toy, or yes, it's cool, but it would never work. And it's simply because they didn't have enough processing power back in those days to really train large enough networks to kind of extract the more complex patterns out of such data. Now, fast forward to today, of course, and TensorFlow was released in 2016, I believe. Of course, at Google, we were developing and using this internally, and we open sourced it in 2016. So we actually were developing prior to that, of course, internally, and then thought, okay, it's now mature enough that is useful to everybody, and of course, we released it to the world. And then after 2016, a couple of years after this, TensorFlow JS was born, because we're like, hey, 69% of the world uses JavaScript for professional development. There should be some equivalent of this for the JavaScript land as well. So that's when TensorFlow JS came out. So of course, we're younger than the original TensorFlow. So we kind of got a lot to catch up with there. But I think with time, we will get the parity. And we're already starting to see a lot of businesses start to use us as well, and so on and so forth. So yes, the short answer there is it's been around for a long time. I'm not sure who exactly invented the perceptron and these kinds of things that are kind of the building blocks of many of the things we use today. But I'm sure if you search on your favorite search engine, you'll find the names of those people as well. But they'll be probably quite far back in history. And many people may have said that they were just had these ideas that were not going to go anywhere ever. And a lot of people, this happens a lot in research and science in the past. And then a few years afterwards, sometimes these ideas that are previously, not thought about much actually become popular because new inventions, new technologies then exist to allow these things to happen. So, and that's another good life story there as well. There's many times in my life where I've been told something is impossible, and then I'll go and solve the problem. And, I think just because someone says it's not possible doesn't mean you should forget about it completely. Sometimes you just need to put it on the back burner for a few years until the technology makes it possible. And remember to go back to it and finish it when you can. So yeah, assuming it's not outside the bounds of science itself, then just leave it there until technology catches up, and then give it another go in the future. So that's my top tip.
Yeah, Ramanathan Aram sir asked a very good question about, like, would like to know his view on advancement in the explainable AI, and
Yeah,
now that's
great
the new
question.
trend. So what's your view on it?
Yeah, I think this is a very important question, and it's an active research area, of course. And just in the last few years, there's been a much more research going into this than prior to that time frame. And of course, what is explainable AI for people who might be new to all of this? Well, traditionally, when you're using a deep learning system, it will work, but it's very hard for the human to explain how it's coming to its answer. As I said, it's just a bunch of mathematics working out typically, and to kind of go through billions of nodes in a network to say why that gave the certain answer is hard for us to visualize. It's simple if you have like a simple linear regression with like a few parameters only, you can actually see how it got to its answer. But as soon as you get to tens of thousands of nodes in a network, it then becomes very hard for the human brain to comprehend. So there's an active research now going into this area to try and figure out, especially for like computer vision, things that are trying to show where like the brain tumor is in a medical image, why it thinks it is that, and it's able to highlight the region that it finds as an interesting area, so the doctor can then verify, oh yes, I do see that as well. That is a good, telltale sign of something. And again, in that case, the human and AI are working together. So you always got the human verification there, because in medical that can be a life-changing decision if you get it wrong. So always have the human in the loop there. But we're starting to see this happen in other industries as well. And I think this is very important and will continue to get better over time as well.
Darshan Solanki has asked, Solanki.
Yeah.
I think if I spelled your name right. If not, sorry. Okay. Darshan has really asked a question. According to Andrew Ng, new invention of model is not the solution to cater a particular problem, but to make it more data centric and enhance data quality is what the world should focus on. What are your thoughts on the upcoming boom on data, the big data and the trend like that?
Yes, I think it's widely accepted in the industry that having good quality data is better than having a lot of worse quality data, let's say. The model is only as good as the data you kind of put into it, garbage in, garbage out, so to speak. And I think especially these days, you need to be very careful about bias as well. It's very easy and unwillingly to create bias in the models that you produce. And just a trivial example of this, I'm just picking off the top of my head right now, is like, imagine you're trying to make a machine learning system to classify voice input. So it's going to be speech to text or something like this. You go and do your research. Maybe you're based in the USA and you get samples from everyone around you, different states, all varieties of people around the US. And you make this really good model that seems to work well on English, let's say. And then you release it to the world and everyone goes and tries it. And maybe people in India or maybe people in England, in the UK try and use it, and it doesn't work. Now, of course, we're all speaking English, but of course, British people and folk over in India as well might have different accents to the US accent, and it will not have been trained on that data. Now, this wasn't intentional. This was a researcher just trying to do something that he or she was passionate about, but they forgot about some community who also speaks English and needs that represented in that training data. So I see this stuff becoming more and more important, and I'm starting to see a lot of startups in the world that are human in the loop data kind of gathering based services. Essentially, we see a lot of those companies and startups becoming more apparent in today's world. And I think it's for exactly that reason. So we can find more higher quality data and to help avoid these biases. When it's just one person working on it, you can actually get a team of people to get a variety of stuff with all the edge cases you might not get in the lab, and help that process. So yes, I think it's a great question, and I think it's a very important thing to think about to encourage better data collection that's more representative of all the different situations someone might use your ML model in. And in the world of JavaScript, I've got to be a little bit biased here towards TensorFlow.js, but in the world of TensorFlow.js, I think that problem is even more important because the average JavaScript engineer comes from many different backgrounds. It's not just academia, but we've got musicians, creatives, and artists trying to use JavaScript with machine learning to do things you never even dreamt of before. And they're going to push our models in ways we've never even thought of using our models. So someone might take body pics to do something that we didn't expect body pics to be used for, but it still needs to work well in that situation, maybe for a dance performance instead of a stationary static image of someone holding their hands up. So, these edge cases like that will make sure the training data is good for those situations as well. But yeah, great question, and thank you for that.
I always wanted to ask you this question because deployment at a scale is a different story. It's not like me writing a cat assisted dog model, deploying it on a mobile application or a Flutter application. That's no big deal because industry is deploying at a scale. So there are fusion algorithms and things like that. So what's the potential of TensorFlow.js that is yet to be demystified by all the developers? Are we just adamant to the fact that TensorFlow.js is an DIY project one, or else is it the production-based, the scalable production-based aspects? What are we still yet to explore in the TensorFlow.js world? Because every TensorFlow version has a new story, and every TensorFlow.js creator has a new story to say. So what's your view on the scalable deployment?
Yeah, so we're starting to see this start to happen now. There's startup companies being produced who are actually focused around doing data science in TensorFlow JS. So all the tools that you're used to having in Python, let's say in a command line, to help you analyze your data sets and things like this. I'm starting to see companies being formed specifically for people using web interfaces powered by TensorFlow JS to analyze the data, refine the data, and produce models from that data, all in the browser, which is really, really cool. I think there's a company called HAL9.ai that's doing this kind of stuff. And there's many others as well that have contacted me on LinkedIn to kind of show their progress over the time. So if you search around, you'll find people starting to do this. As I said, we are a younger team, so these things are now only starting to happen. But it's very few times in our lives that we're able to be at the beginning of a new industry like this. I was thankful enough to grow up with the birth of the internet pretty much. I was one of the first people in my kind of city to get the internet back in the day. And it was really exciting because this is a whole new thing and you get to learn it as it's happening. And the same is happening right now with TensorFlow JS, machine learning in the web browser and beyond. We can run on server side as well. We can run on native applications, desktop native applications, mobile native applications, and even on Raspberry Pis with Node.js. So we can run everywhere, which is one of our unique selling points versus other forms of TensorFlow, which typically on the server or on a specific device. That is a unique property of TensorFlow JS, but we're very transferable. And of course, if you already have a team that's writing stuff in JavaScript, it means you don't need to retrain that team. Well, you need to retrain them in machine learning, of course, but you can still use the language that they love already, which is very helpful. And if you're trying to get it out there for people to use, there's no dependencies to install necessarily. If you're doing it on the front end, you can just send a link and the machine learning demo will just work, which is not the same if you're trying to do things maybe in Python land in TensorFlow. You've got to install Linux, you've got to install TensorFlow, you've got to install the CUDA drivers, you've got to clone the GitHub repository, you have to read the README. And if all that works out and you understood the README of someone you've never met before, then maybe you can run the demo. So with TensorFlow JS, I think we're giving researchers and individuals the ability to get more eyes on their projects and allow people to share that and go more viral with all this kind of stuff that they're producing, and allow people to try this on device without any installation, which is really great. And often creates many creative ideas with the people that start tinkering with that. And of course, you can still write in Python if you wish, but TensorFlow JS is that one extra deployment path you can take to get the reach and scale of the web if you choose to do that.
Yeah, Aman has asked an amazing question about like for almost all the vaccines, and is the AI degrees and PhDs related? I'll come to that because the prior questions that I'll be asking after before this question is actually something like, the value of education that you are actually giving. I know you have influenced a lot of people out there for like doing beyond their comfort zone, doing beyond and achieving something more. So I want to ask you, like, what's the value of education and how has this developer advocacy, the developer advocates made that influence in the world today uh, for the development process? Like, it's a whole new level of approach that everybody gives after, I have been influenced by a lot of solution architects. I have been influenced by a lot of engineers who are called as fossils, like 20, 30 years in the industry. Like, they're amazing people. They are like, they themselves call like, we are just fossils here. We don't mind about anything. We just come, we just code, and we just go out. So what's your view on the education and the advocacy playing role in the present day's development? I think I interviewed somebody called as John Willis, who is also called as one of the father of DevOps. And he literally told me in such a way that, we were the only 3 cloud advocates there and there were nobody else in the world. So it started from there. So I want to ask you, like, what's the influence of educating people through developer advocacy?
Okay. So I'll take the first part of the question, which is the role of like education first, and then I'll talk about the role of advocacy as well. So the first part, if you're trying to get a job in machine learning or developer advocacy, I'm looking at the question on the screen there as well. Someone's asking about having a master's or PhD degree, this kind of stuff. So obviously, having a degree can help in order to stand out on the CV on paper. But even companies like Google don't require you to have a degree to work at Google, for example. it's an advantage. And when you're competing with millions of other people, it does help you to stand out a little bit. Not much these days because everyone has a degree these days, but a little bit more than someone who doesn't maybe. But it doesn't mean you can't get a job if you don't have a degree in that. What's more important, to me at least, is showing that you are capable and have the knowledge of doing the job that is being asked of you. So your personal portfolio is very important. What open source projects have you contributed to? What have you created by yourself and are passionate about? Typically at startups and even large companies, they're looking for people who are very proactive, not just being told what to do, but they're able to go and create things without being told as well, and that kind of stuff. And so it's important not just to read a book and memorize it and regurgitate the book, but actually use the knowledge you've gained through a degree or through a training course or through the internet, however it is that you learnt it, but actually use it to show that you can do something with that knowledge. And that's the key thing that I see a lot of people not doing, is that they've got the knowledge, but they're not using it. And so compared to the other people who are using it, they don't stand out as much. And that, I'm talking from experience from my time in startup companies, at larger companies, and people who I've met at other companies as well. So I see a theme in that area there. Now, the second part about how does developer advocacy enable the education. So part of my role, of course, is to help people who are unfamiliar with TensorFlow.js get started with it. And you'll see that I'm pushing out various code labs and tutorials, presentations, sometimes Ask Me Anything's kind of like this as well, just to kind of show people how they can get started and it's not so scary. And, I can guarantee that I can describe something to someone even with no engineering background, and they'll be able to recognize an object in the house by the end of that conversation within 30 minutes. And there's a great phrase I like from a friend of mine back in England who said, simplicity is a complex art. And I think this is the essence of developer advocacy, is that you need to know the subject well enough to be able to explain it simply. Too often in engineering and science and related disciplines, people are very good at talking very academically, but they're not very good at explaining it simply such that they can go to the fundamentals to explain it so another human can then also understand, unless they've got subject matter expert experience in that domain. So and people often forget that people aren't just born with this inherent knowledge of machine learning. I actually didn't get into machine learning until around 2016 when TensorFlow came out. That's when I started my machine learning journey. Before that, I did one module of AI in my degree back in the day. But in 2004, AI was a very different thing. I was actually studying computational neuroscience, not AI as we know it today. TensorFlow didn't exist back then. So even then, it was very different to what we do today. So yeah, the short answer is keep learning and stay relevant and produce stuff with the knowledge that you're gaining, and continually do that. Computer science and related fields is one of the few industries out there which you have to be continually up to date year after year. Otherwise, your employability fades pretty quickly. So yeah, staying up to date and active is key there for sure. But yes, a degree can help, but it's not required to get into the field. More about the passion and being proactive and showing the proof that you can do it. So, if I interview you and I ask you a question about something you've done, you should be able to explain it confidently, simply, and maybe elaborate on how you might expand it in the future and get in like a nerdy conversation with a good friend, and if you can't do that, then did you really write the code? But you got to just be confident in that. So we'll make sure you're actually working at the level needed to do the job, and that's all there is to it. Sounds simple, right? But obviously, it just takes practice.
Yeah, every session you have the same background almost. Like every time that you have it, that scrolling always says your Twitter and the number of subscribers in the YouTube, and that's always there. But I wanted to ask you beyond that intelligence, like who was Jason Myers during the age of 15, 20, 25? Last 5 questions from my side, and I'll be open for the Q&A because
Sure.
now Aman Singh the previous question was also asked by Aman Singh, and now the question is also asked by Aman Singh. Like, can self-learning be used for creating chess puzzles and knowing its difficulty, like reinforcement learning and all these? I just want to ask the 15-year-old Jason Myers, did you ever dream of building something on TensorFlow JS or else on anything that
The
is
short
on
answer
TensorFlow?
is 15-year-old Jason wanted to be a pilot in the Royal Air Force in England. Technology was something on the side that I was curious about, but I was just starting to learning to program in my teens, actually early teens, like 12, 13. I started with Visual Basic, actually, Visual Basic 6 back in the old days. And that was my introduction to programming. And I could make lots of cool tools and utilities. And my code was horrible back then, looking back at it now. But that was my starting point. Now, for various reasons, I didn't end up going into the Air Force, and that became a hobby. You may have saw on my LinkedIn recently that I just completed a course to do wing walking. So I learned how to walk on the wing of a flying airplane recently. I said, I still love flying, and that's my hobby now instead. But in my teens, I then realized that technology was probably a better career route for me at that point in time of my life. I actually had to take a year out to earn enough money to send myself to university. So I did a gap year after high school. I took 1 year to take a job to help pay the bills for my family and also to save some money for university. And then a year after that, I went to university. So it was actually 1 year later than expected to go to university. I studied computer science at the University of Bristol in England, and I specialized in reality mining, web technologies, pseudo-anonymous social networking, and these kinds of areas. And it was in that degree that I realized that I was passionate about both front end and back end, because you can write the best back end with the most complex algorithm you've ever designed, but if it doesn't have a good UX and a good front end for everyone to use, no one's going to use it. And I realized that very early on. So from 2004 onwards, I always defined myself as a hybrid developer, overlapping the creative industry and the technical industries and combining them together. That was kind of my unique selling point, if you will. This is before creative technologists and these hybrid engineers even existed generally. I think I was one of the first people to kind of be thinking along those lines. And this is partly due to the fact that our head of computer science there really pushed for this. And he said, like, this is going to be important. He doesn't know the exact specifics of it yet, but he knows that these skills are important to have in combination. And I can't thank him enough for forcing me to go down that route, because I still use those learnings today. And even for our thesis, our final year thesis in computer science, we had to produce not only a novel piece of research, but something that could be a business as well. And this was really the only university in England who had this requirement. I didn't do a business and computer science degree. My degree was Masters of Engineering, Computer Science, 4-year course, no business involved. However, they forced you to think like a businessman in addition to doing the computer science. And I think that is another thing that has helped me be innovative in my career at Google and in startups before that, which has allowed me to stand out as well. And I encourage everyone who's listening right now to think about, what are your two passions? For me, it was creativity and technology, but maybe yours is music and technology, or sports and technology. And I guarantee if you become a hybrid of those two worlds, so if you have a really good passion hobby and you're also good at programming, let's say, if you combine those together, you can then be known as the person who's great at those intersection of those two things. And obviously themes and things that are popular change over time, but you'll find that there will be startups that overlap these areas, and you'll have an edge there at those startups and companies, which may end up becoming the next Spotify or the next fitness coach, like what was it, Peloton or something like this, whatever it might be. So, if you have interest in these intersecting areas, embrace them both. You don't have to give up the other passion. Use your engineering skills with your other passion. Maybe it's photography, maybe it's art, maybe whatever it is, but combine them and see what you can do there and push the boundaries of both worlds together. So I digressed a little bit there, but then I graduated. I joined an investment bank for 1 day. I then quit the investment bank after 1 day. So that was my experience of the finance world. I didn't like it so much. And the lesson I learned from that was, you're going to have times in life where you have to make scary decisions. I just graduated from university. I had a lot of debt because I took student loan to pay for the university bills, and I had no backup plan. So, but I just wasn't feeling it. And sometimes you've got to like do what's right for yourself. So I quit that. I moved back to Bristol, and I ended up working for a semiconductor company called Exmos, which was founded by the head of computer science at Bristol. He just so happened to be looking for a web engineer to help him make that startup company. And I then joined Exmos. I learned to do many things there. Startup companies, I highly encourage people doing in their earlier years. If you're in your 20s or so, startup companies are a good way to learn a lot of things very quickly and get a lot of responsibility and potentially very high reward if you get lucky and manage to go to a successful one. Now, of course, 65-70% of startups will fail in the first year of existence. So sometimes maybe look for something a little bit longer than a year of existence to have a bit more stability. Or if they've got Series B, Series C funding, then that's also good as well, to give some stability there. But yeah, startups are very exciting. And I managed to learn many things there. Not only did I do web engineering, but I also did kind of photography, and I did digital marketing. I did community growth stuff. I did a lot of other activities in addition, even 3D modeling using Autodesk Maya for the hardware we were selling. I couldn't get the photos to not have reflections, so I ended up having to learn how to model them in 3D to get the perfect product shots for them. And there's only 20 people when I joined that startup or something like this, so no one else could do it. So someone just had to learn that skill and do it. So startups are very exciting. Once you've done startups, or in my case, I then moved into doing my own web company. And then after that, I got an offer at Google to join them as a web engineer. And then after web engineering at Google, I moved into creative engineering, which is where I went wide. So all that previous time I was going narrow into web engineering, essentially, and design and UX. And then I went wide with creative engineering to basically know a little bit about every technology out there, which is just dangerous enough so I could combine them to make new prototypes that had never been made before for some of Google's top clients around the world, to help tell their stories. And then that's where I learned about machine learning, augmented reality, virtuality, all these kinds of things, projection mapping, a little bit of robotics, all this kind of stuff. And that's where I could see all the trees in the forest. And then I went narrow again. So now I'm back just climbing the machine learning tree now to go narrow again. So in your lifetime, you should try and do this kind of go narrow, go really detailed, but then go wide, because time will have passed. There might be other fruit to be harvested. Go wide, see what there is, have a sampling of all of that, and then pick your next area you want to go narrow in, and then go narrow, and just keep doing that throughout your career. And that's where I am now. I'm back now on the narrow tree again with machine learning. So hoping to go deeper on that one.
Yeah. There's a brain in the background which says that you are also a very big enthusiast in terms of the computational neuroscience and also the understanding of the brain. I know that. So I just want to ask you this one silly question, because, in most of the TED Talks, they have even said that if you would have said what computers can do today, 10 years before, like what can computers do today, I would have. And also there are other ways in which people have really told, like, okay, I'm building something, so how to get satisfied with the intent of machine learning. And also scientists have also told that we have not understood the brain completely, but we're trying to build a brain on a burning box, that is CPU, GPU, and the things like that. So I want to ask you this one question: what's the future advancement of machine learning, AI, or anything? Can that AGI be the reality? Can we actually have a human built on a machine? What's that all about? What's that advancement in the intelligence that we are going to see tomorrow? That's my question. And I'm also sure that this can be answered for Aman Singh's question. Can self-learning be used for creating chess puzzle, for knowing the difficulty, like understanding what this neural network is also all about? You can answer those two questions together.
Yeah. So that's a very hard question to project for like the long distant future. However, in the short term, I think right now, the most popular form of machine learning is supervised learning, which is where you have labeled training data and the machine learning learns from that labeled training data. Now, there's other types of machine learning that are kind of in its infancy right now, such as the reinforcement learning, which is where the computer will essentially kind of, like for gaming, it will just play the game continuously and it will learn from its mistakes over time without any knowledge of how to play the game. It will learn by itself, so to speak, just like, as a baby would if they were just presented with a controller and trying to, okay, all you need to know is to get the high score. That's all your thing you're trying to maximize. Go figure out how to do it. The other type of machine learning is unsupervised learning, which is where the data is not labeled. So you've got a bunch of data, but you know there might be like, maybe it contains like data for different species of flower, maybe. And maybe you know there's roughly 10 species of flower in there, but you don't know which data belongs to which. And you want it to go and learn from it by itself and to automatically figure out the categories and how to split that data up in a meaningful way. So I think these areas will get more growth in terms of research over the next decade or two. And that's going to be a very interesting area. And then the third area I think will be interesting is I've started to see some things around quantum machine learning as well. And I am not the person to ask any more questions about quantum machine learning. I do not understand it myself yet, but there's others in the world who do, maybe like 5 people, but they exist somewhere. And I think that's something that's going to be very interesting in the future, long term as well. But I don't fully understand like the ways in which that will be leveraged yet. I hopefully can come back to you maybe 5 to 10 years and give you a better update on that one, because that is an active area of research. But I need to learn more on that area myself too.
Yeah, the Aman's questions. Can self-learning be used for creating chess puzzles or anything like that for understanding the difficulties? So that's his question.
So there are models out there that can be generative in terms of generating new game types and this kind of thing. So if you're referring to that kind of stuff for creating new types of puzzles, then yes, there are models that can do that kind of thing. Knowing the difficulty, I'm not entirely sure what he means by that. I guess you could score a puzzle based on the number of paths you can take in the game. So obviously, like the game Go is more difficult technically than chess because there's many more moves you can make. But I don't think you need machine learning to calculate that. That's just a mathematical thing that you need to calculate. What are the number of options I can take at point N in the game? And you keep doing that, you can figure out how many possibilities there are, and that can give you an idea of the complexity of the game. So not everything requires machine learning to figure out. But yes, there are generative models if you're trying to generate maps for games or like mazes and puzzles and things like that. There are generative models that can do that given enough training data. Yeah.
Yeah, and I think probably he asked regarding the understanding of the neural network. Like he's also asking about reinforcement learning, I think so. Probably like TensorFlow.js doesn't have kind of a sturdy algorithmic approach. Like, you know, you can't really build a petabyte scale system into it, but you can do something which is very close to like at least gigabytes of like data sets trained on it, and you can really
For
work
sure.
on it.
It depends where you're running, of course. In the web browser, you don't have petabytes of RAM, or so that's not going to happen. But you can run in Node.js. Remember, TensorFlow just runs in Node, and our Node.js implementation talks to the same C++ backend as Python. So it's exactly the same as that. And on the backend, it's just how big is your hard drive and RAM on the server at that point. So as long as you can write the algorithms to work at that scale and to distribute the load across multiple servers, then there's no reason why you couldn't do that. But yes, in TensorFlow.js, that's probably an area that needs more active development to get parity with the Python equivalents for the TFX stuff and all that kind of stuff. So maybe one day in the future, there'll be a JS TFX kind of pipeline as well for the large scale stuff too. That'd be cool.
Yeah, you know, I'm also waiting for it. TFX is much potential. Like it has more potential than what you think. You know, we still complain that our H5 PMML model, pickle model always dies in the Jupyter notebook or the Google Colab notebook. I think probably that's going to change the stereotype of how we are going to see the deployment, because TensorFlow.js is very easy in terms of building such kind of a sturdy system in order to make some prediction at least. I think that's the potential that I'm also waiting for. So Sneha asks, what's your view on users over trusting or over under trusting ML models? What are the industry methodologies adopted in the industry or for compliance or policies of AI human interaction?
Yeah, I think that's a great question. And I think it depends on your experience with machine learning as to if you over or under trust it. I see a lot of people new to machine learning, maybe over trusting the results, thinking this is the final answer. rather than interpreting it and actually doing some analysis on it, maybe. And I see people who have been in the industry a long time, often just using it as a ends to a means to come to some other calculation, which they then, take that result and merge it with other results to then come to some decision whether to do something or not, right? So it's, I think machine learning, as you spoke about at the beginning of this conversation, is the model that you produce is as good as the data that you train upon. And if you have a good data set that's representative of all the different situations that you're expecting to see it being run in the real world, then you can build a very robust model that might work 99.9% of the time and be correct, and that's great. But of course, there is that 0.1% that will be wrong, and when you're working with millions of ratings, maybe that could be a large number, and you do need to remember that it's not always going to be correct, and what you should do in that situation. And you should be asking yourself questions around, do I want to have more false positives or false negatives and that kind of stuff? And what's better in the situation that you're actually dealing with? If you're working in healthcare, having a false positive or false negative could be disastrous, right? So you want to really err on the side of like asking a human to then check versus assuming everything to be correct. I think, as I said before, human plus machine learning is a really great middle ground right now for us, as we're learning to get better at making our machine learning models. In the grand scheme of things, remember, TensorFlow came out in 2016. Like, no one really has more than 5 years experience at this, at least in the popular sense of the word. I'm sure there's many researchers who've been looking at this for many, many years before that. But generally speaking, most people you bump into who are in the riding the wave right now have only been around in it for like 5 years. So there's much, much more research to be had and to go before we have much more robust things in the future. I just had a talk recently on our Made with TensorFlow JS YouTube channel, YouTube playlist on the TensorFlow channel, where someone created adversarial.js, which allows you to break neural networks for computer vision. And essentially, he can take any image and he can add some noise to it that is you can't see with the human eye, is indistinguishable to the human eye. But what is actually a cat can be classified as a penguin, for example, just by changing some of the data in the image. And of course, as a human, we wouldn't be fooled by this, but current machine learning models are. And there's actually active research now to make models more robust to this kind of attack, where there's just noise in the image, but the actual structure of the the objects of the image, like the shapes in the image, should count more. Not just the patterns, but the shapes and things should also count. So that way, the noise in the pattern is less relevant there. So that's an ongoing area of research, and it's something that might be very useful. I saw another question there. What's kind of cool to research into these days? I think, making models more robust is a very cool research area too, to kind of figure out how we can get a more human-like understanding of what we're classifying, rather than it being fooled because it's just mathematics working out underneath the scenes there. How can we make that more robust to be not fooled by these kind of adversarial attacks and that kind of thing? That could be a good research area right now.
Yeah, guys, I've given you the unmute option to all of you. I think you guys can ask the question. I think last question from Aman Singh. No, you can ask any questions, but till 10:30, so you guys can ask any question. So it's 30 minutes, so be quick. So GANs are being very complex computationally. So is the new implementation of GANs on the TensorFlow JS be most efficient and fast enough to that it can be used in various applications? Like, is it fast enough to use it in various applications also? That's the question.
Again, it depends on the model architecture that you're using, how big it is, how many computations you need to execute, and on what device are you executing. I've seen GANs in JavaScript work very well for things like cartoons, for example. There's one that takes an input image and converts it to looking like a cartoon, I think it's like a anime style kind of cartoon generator. And it works really well. And you can run it, I think, in real time from the webcam data, and you get like 15, 20 frames per second on that one, I think. But again, I tried that on my desktop. If I ran the same thing on my mobile phone, maybe it might be 1 frame per second, who knows? So it does depend on the device you're running on, of course. Every device has a different processor, a different amount of RAM, different GPU. So you need to find the sweet spot there. Now, we are having advancements in browser technology that allows us to get better performance out of the hardware we are running on, especially on older devices. So currently under the flags in Chrome, you can enable SIMD and multi-threading. And with that, some other models can go 2, 3, 4 times faster than they currently do, which is amazing on the CPU. And that's really good for mobile devices that are heavily CPU based. And there's new web standards coming out called WebNN, Web Neural Network, and also WebGPU. And both of these will allow more native level implementations of common code structures that are used in machine learning, so that TensorFlow.js and other libraries and anyone else can leverage these lower level implementations to get even faster performance in the browser using JavaScript, which would be amazing. So these standards are a work in progress with the W3C committee. So watch this space. These things take a few years to mature and define, but the future is bright, and I'm very excited to see how this progresses. And things are only going to get faster with time for sure. And yeah, we'll see more of this GAN work, I'm sure, being converted over. And I encourage people who are listening today, who are familiar with Python, who have the knowledge to transfer a model into TensorFlow.js. If you know how to build models from scratch, come try our API out. We've got the same, very similar API to TensorFlow Core. If you know how to program the Keras, we have a layers API that had the same function definitions as Keras pretty much. So you can create things in JavaScript just like you do in Python. And we need more people like that transferring some of these research papers that are coming out into JavaScript land so we can run natively in JS. There's also the ability to take a saved model from Python and run it through a command line converter to work in JS. But of course, that won't be as efficient because you're just taking in a model dump and then just converting it over. It all might work, but maybe not the most efficient. If you're an ML researcher, you know how to be efficient with your model architectures, then making that in JavaScript with our layers API, something from the ground up, can lead to some much faster models for our community. So I'd love to see more people getting involved on the research side for JS too. And of course, you might get a lot of benefit by that because you'll be known as the researcher who's involved in these things because people can try that in their browser, and that means they're going to share it on LinkedIn and Twitter and places much faster than a Python-based piece of research, which maybe 10,000 people might try, but with the web, maybe millions might try. So you'll get much more eyes on your work if you do that too. So top tip.
Yes, guys, I'm going to unmute you all and I'm going to give an access to start your video. So do ask some technical questions. And also, Abhilash, you can ask any amount of questions that you want. You have less time now. And I think, yep, you can ask any questions.
Sure. Look forward to any questions that come live.
Hi, Jason.
Hello.
So I was working on a startup where they were trying to build systems, NLP systems, which are understandable, but still they are not planning to use neural networks. Then I started thinking, I mean, neural networks are like essential things to create functions which we cannot understand, right? So, but the biggest problem right now in NLP is like we are unable to give the metadata which we know, right? Like in all the language models which are out there, they are like they understand the data by themselves without having the core knowledge of what the entities mean. So I think people are doing research in the direction where we can feed metadata which we know about the language or the basic structures of the language to neural networks externally, so that they can understand things better, like question answering systems or something like that. So what do you think, what is your opinion in the research, in this research direction?
Yeah, I think this is a growing area, and I think you've seen like things like BERT and things coming out, which are making things very interesting these days in the natural language processing world. And this is going to get better over time. Of course, the specifics of this we can probably take offline in a dedicated conversation with one of our engineers who specializes in NLP. But essentially, yeah, I mean, it depends what you're trying to achieve. Like I just recently wrote a code lab for comment spam detection, for example, and I show you how to train a model based on the tokenization of words, and then using those tokenizations to then learn automatically what sentences are more likely to be spam or not, and then automatically filtering out the comments on a blog post, for example. So something like that, I think, is very achievable with pre-built models that you just retrain without having to specify too much. It can learn from that quite nicely. But some of the more advanced things that you're talking about, where maybe you're trying to really understand language to ask questions and answers and this kind of stuff, again, this is still something. There's some word association stuff going on there, so you can kind of, there's some overlap in the research there. But I think this stuff will take a little bit longer to mature. But we're starting to see good results in this space too, with all the like GPT stuff as well, and of course BERT and all these other areas. I think the next few years we'll see more research in there. There's a great YouTube channel called 2-Minute Papers, if you've not heard of that already. I highly recommend checking out as well, which summarizes some of the latest advancements in all of the machine learning fields, from natural language processing to GANs and everything in between. And if you're looking for advancements there, I highly recommend checking out his channel to get the 2 minutes overview of these papers. And then if you like it, you can then go to the paper and learn more to see how to tackle that problem in the way that the author has done. If you've got a specific question afterwards, feel free to reach out to me on LinkedIn or Twitter, and I can try and follow up with someone from my team who's actually more experienced on the natural language processing side. Most of my time on TensorFlow.js so far has actually been more on the object detection and vision side right now, but I did write my first tutorial on spam detection recently, so I'm starting to explore that area more. But yes, this will improve over time, and it's very exciting time to get involved in that.
Any more questions, please do ask. Jason Myers is live in front of you virtually, and don't miss this chance of asking any question. I think Abhilash had many questions regarding his masters. I think you can ask that. Sarah, but I want to ask you one question: how to approach a problem statement? That's my question.
Yeah, I mean, if you have a problem, the only thing you need to do is keep breaking it down until it's into small enough chunks that you understand, right? So it's kind of like, well, if you've gone to university in your first year, they typically give you a problem and they'll break it down into parts you need to complete the coursework. You need to be good at doing that yourself rather than the lecturer telling you to show you how to do that. So for an unknown problem, how do I break this down into manageable parts? What parts are unknown? Okay, if they're unknown, can I find the answer to that unknown? If not, maybe I need to wait a few years before the research exists to do so, or the science exists, or the technology exists. If I can, I need to go and learn that. You might find then a whole bunch of other unknowns you then need to research as well. It kind of keeps breaking down to smaller and smaller parts until at some point you go, okay, well, this is just a function that's going to be defined like this. And then you keep working your way back up that stack until you've implemented all of the things and join them all together. And fingers crossed, it works. Of course, typically, once you've got something working, it then becomes an optimization problem. You get something working, but it's really slow. So then you are then going through everything again, trying to optimize it to make it faster, more efficient in terms of memory, in terms of speed, that kind of stuff. So getting good at that as well can help you further down the line as well.
Yes, sir. I think, Abhilash, you have any questions?
Yeah. Hi, Jason.
Hello.
I'm in a month, I'll be starting my master's. So basically, I'm really confused about what kind of work I need to do in my master's so that I can have a great career in AI. I am already an AI engineer, but I'm not. I feel like I don't know a lot about it. That's why I'm doing masters. And again, should it be like more oriented towards the practical applications or more towards research, or should there be a balance? I don't know. I feel like if I go into
Yeah, no, I think that's a great question. And as I said, for my degree, I was also doing masters, not in AI and computer science, but having a balance for me was very useful because if you do research for the sake of research and you produce something that is like 0.1% more accurate than the cutting edge model, that's nice. But I know you didn't really, starting with something brand new that never existed before, that solves a new problem that exists and can help people, I think is more making a bigger difference to the world than making something go 1% faster or something like this. And I think with time, this kind of lower hanging fruit of making something a bit more efficient or whatever, it's going to happen. People will do that hardware will get better as well. These things will execute faster naturally, even if you don't do anything. But yeah, model architectures as well. Of course, it's good to invent new versions of that are more efficient as well. There's nothing wrong with that. But I think if you can solve a problem in your life or someone else's life that you see as a common problem, and it can have some social good on the world as well, or could be turned into a startup company even, and so this could be the algorithm that allows compression for some new type of compression that saves the internet from the current bandwidth overload that we're having right now, whatever it might be. And I think that's very novel and very interesting research. And I think NVIDIA is a really good case study here. Some of their research I'm always amazed by, that recently they actually solved this bandwidth problem by using GANs so what they do is they take one image from your webcam as the initial image. They send that image across the network, so 10 kilobytes, and then they just send the pose of your face to then recreate in real time on the other side your face in HD quality. So then the network bandwidth, instead of megabits per second, you can actually use 0.5 kilobits per second. And even people in a rural connection on Wi-Fi can actually have HD video quality of a person's upper body, and it's generated in real time. So, research like that really excites me, and I'd encourage you to think of problems like this in the world, and see what you might be able to do there. And of course, if you can't think of anything, there's always the backup plan of making things a little bit faster or whatever else. But I encourage you to push yourself to think about combining industries and seeing how you could give birth to a new baby by combining things together and make something that didn't exist before, and be known as the father of that, literally. So that'd be very cool. So I look forward to seeing what you create.
Thank you. I'll definitely let you know.
Cool.
Yep, that is fine. And thank you so much, sir. Thank you so much for this amazing podcast. And it was a dream come true to me, because you are one of my heroes and I did a podcast with you. And guys, the comment section, chat section down there, I'll pasted the link for my channel. Do subscribe there. When I release Jason Maya's podcast after editing with all the appropriate overlays and things like that, it will be out and up and running for you on the YouTube. So thank you so much, Jason, sir. It was an amazing podcast that I did. I think I'm so honored today that I had Jason Myers on my podcast. And thank you so much.
Very kind of you. It's great to be here. And yeah, if anyone watching, feel free to add me on Twitter or LinkedIn. I'm at Jason_Mayes, Mayes on Twitter, or just search my name on LinkedIn and you'll probably find me. I'm the TensorFlow.js guy. So yeah, I'll be on LinkedIn as well. And just make sure you send a message saying that you met me at this show, so that I know to add you, because I get a lot of requests from people who might be spammers and things as well. So make sure you just send a personalized message as to why you want to connect, so I know you're a real human being. And that'd be great.
Thank you so much. Thank you so much.